So, welcome everyone. My name is Akshay, and welcome to our channel. So, this is our GFG POTD streak of day 89. So, hope you guys are all doing well, taking care of yourself, learning and studying. So, if you're new to this channel, please like, share, and subscribe so that we can learn, share, and grow together, right? So, let's get to the today's question. Today's question is about find the first node of loop in linked list. Uh, it's the category is easy here and it's a points too. So let's just read the question and jump to the all the approaches and the solutions we can have here. So given a single linked list of n nodes, find the first node of loop. If the linked list has a loop, okay, so if a loop is present, return the node data of the first node of the loop, else return -1. So this is a very standard question and a very good question of linked list. So if you have studied data structures in of linked list of data structures, then you must have encountered this problem. But if you have not, so let's deep dive into this question. So we need to find if there a loop exists or not. Like this, you can like here you can see 3, 2, 4, 5 are in a loop, right? 5 is again pointing to 3, and they're saying if a loop exists, then print the first node. That the first node of this cycle is 3, right? So they are printing 3. Similarly for the second test case, so since there is no loop, so they return -1, and the constraint is 10 power 5. Okay, so let's get started. So suppose this question would just have been that to find the loop exist or not. That's just the question. Just imagine for a time interval. So what we can do now? So what should be the brute force that we could have applied? So I am saying that this is the question: 1, 2, 3, 3 to 4, 2 to 4, 5, and this is the loop, right? So what should be the brute force that comes to a mind? I can say, because linked list is like we do the traversal in the forward direction wherever the pointer is saying. In the singly linked list we move forward, or in the doubly we can move reverse also. So the brute force I can see is just keep on traversing, and and this is the question of just to find the loop, just to find the loop. So I can say that just keep on traversing and mark the visited nodes with such a number that that number shouldn't be present in any of such node. Let's say -1, right? So I'll mark this as -1. I visited this node, then I visited this node also, -4 also, and marked with the same number as -1. So if I again traverse back from this point, so I will see that the pointer is pointing to this one, right? And I keep on while I was traversing and keep on marking the nodes as -1, as saying that this is the node which we have visited. So if it points against to -1, then I can say that the loop exists, right? So for this naive approach, we can say we can find that the loop exists, but we cannot find that what should be the exact value of this starting node, right? So there is one other algorithm. There's a very standard algorithm which is known as Floyd cycle detection, right? So before moving ahead to what Floyd cycle detection is, let me give you a very uh, clear understanding, a very basic thing that you will all must agree with me. So if I say that this is a circle and okay, this is a circle. So suppose this is a circular racetrack. Okay, this is a racetrack, and in the evening, you along with one of your friend, let's say your name is A, and with your friend B, you always go in evening to run on this track, right? So let's say A start from this point, and his friend B starts from this point, any random point, either it be uh, in this section or in the below section. So if I say that in this circular track, it's been divided into divisions. There are divisions, right? Let's say we have the divisions like this, like this, like this. And A can jump from here to here in one step, and then it can jump from to another division, right? So if I say that A is moving with speed 1, is moving with, let's say, jumping one division, moving with one division, right? And B is moving with two division. So is it very logical to say that they will both meet at one point? That division can be randomly chosen from here, but they will meet, right? So why I'm saying this? let's just dry run it. So suppose A move to this pointer, right? And B is moving two times, right? So B, as you can see, B meets here only, right? So B meets here only. So suppose A was not here initially. Let's say A was not here and A was at this point, right? And A is moving ahead with one division. So from A is now moved from here to here, and B moved from this point to this point, right? Okay, now again A moved with one division, that is here, and the B moved with two division, that A comma B. So see, they are meeting at one point, and it is very logical to say that if with the circular track and there is a divisions decided there, then if one is moving with a double speed respective to another, then you may have said the respective relative motion also, they will meet at one point, right? And since it is a circular track they are meeting, so we can say that if they are meeting, that means that loop exists. That means that this track was circular. If this was a linear track, right, and A would have started from here and B would have started from here, and if B moves one step and uh, A moves as two step ahead, right? Or you can say that A is here and B is here, and A is moving with two step ahead, two step, and B is moving with one step ahead. It cannot catch, right? It cannot catch. B cannot catch A. We cannot catch it. They will not meet at any point, and you can say that the track was not circular. There was no loop there, right? This similar intuition is given by the Floyd cycle detection. What it says is, let's make a fast pointer. Let's make a fast pointer which moves two times, and let's make a slow pointer which moves just once, right? And okay, so slow will move once, right? So slow will, if it move once, it will come to three. Let me change the color. It will come to 3 and the fast will come here, right? In the second iteration, in the second iteration, slow will come where? Okay, let me write it down first. And I'll use now the orange color. So slow comes here, and the second iteration, slow will come to 3, slow will come to 2, and F will come to this one, right? And in the third iteration, slow will come to 4 and 5, and this fast pointer will come to this thing, right? At 2, right? And now let's taking a new color, and slow will move from 4 to 5. I'm showing it here, and 5 will move two steps side, that is 2 to 5. And you can see that S and F are meeting at one point, and I can say that the loop exists. A similar intuition given by the Floyd washer, just a relative motion kind of thing, right? So that's the case. So coding this logic will assure us that the loop exists. So let's code that thing first, and then we will discuss further. Okay, so let's make a slow pointer. Node slow, it's pointing to head, and node fast is pointing to head, right? Now let's move. So fast is moving, right? So fast should not be equals to null, and fast is moving ahead, right? So I have to make sure that fast dot next is not equals to null, right? So let's move the slow pointer just once. So slow equals to slow dot next, and fast is equals to fast dot next next, right? So I have a condition now. If this slow and fast pointer meets at some point that is pointing to the same node, then I will say that I have found that I have found that I have found loop exist, or you say cycle exist, right? And if the cycle exists, I need to find what's the starting node. And as you can see in the paint, that this pointer S and F meet at 5, right? It does not guarantees you that this slow pointer and fast pointer will meet at this starting point. It does not guarantee you. It can meet anywhere, right? It depends on the number of nodes you have, and the motion they are in. The moving first ahead, and then fast pointer moving two times ahead. So we have to generalize something. So let's generalize it using some variables. Okay, so I'll be giving you one proof here. Try to listen it carefully and try to understand it. So let's say you have this branch. Let me use some different colors. You have this list like that. You have three nodes here, right? And starting from, there are multiple nodes in these, right? And starting from this node, a loop exists. So let's say loop exists, and you have till this thing. So this is the loop, and I know, and I'm specifying some constraint that I know that this is the length m, right? And let's say slow and fast pointer meets here, and I'm saying that this length is from here to here, it is k length, right? And this whole length, this loop length is n, like the number of nodes in the loop is n. So what I can say that the distance traveled by slow, I can say that the distance traveled by slow, if I do 2 times, that will be equals to distance traveled by fast pointer. I can say that, right? And let's assume that the distance traveled by the slow pointer, first of all, you can say that m plus k will be there in both of the loop. As you can say, the S and F is here. That means it has started from here. Slow pointer and F pointer started from here, right? So they must have traveled this length M and this K length where they met, right? But they would have traveled some extra miles also. So let's say that X is the number of cycles made by slow pointer in this loop. Or if I say that number of cycles covered by slow in loop. By loop, I'm saying this loop where the cycle exists, right? And y is the number of cycles by fast, let's say. So what can I say? The no, if x is the number of cycles, and each cycle I have said that there are n nodes there, right? So I can say that it has covered x star n nodes extra in regard to m plus k, right? And this is 2. And I can say for the same thing for the y that it has covered y star n nodes extra, right? With regard to m plus k, right? This point is clear. So let's rearrange now. So I can say that it will be 2m plus 2k plus 2xn, and I can say here is m plus k plus yn, right? Then I can say moving the m and k in one side, so I will say that m plus k, taking the n as common, and I can say y minus x, right? So what this line, these are all the mathematical things. You do not have any objection here. You cannot, must not have any objection till this point. So from this mathematical equation, what can I say? What can I say? That m plus k is multiple of what? N? I can say that? Yes or no? I can say that. Okay. Try to understand this point. It's very easy that I'm writing that m plus k is something equals to n times something, right? That means that n is multiple of m plus k, right? M plus k is multiple of n. I hope that is clear to you. Okay. So let's move ahead. So saying this point that m plus k is multiple of n, and I declared in the first statement that the number of nodes in this cycle, in this cycle is n, and I know in the first statement I also declared that from this node to this node it is k, and using this statement I can say that the rest of the nodes remaining has the length of what? M. I can say that using this line. I hope that is pretty clear to you. So now here comes our logic. So this is s comma f meeting at some point, and by which we are saying that the loop exists. And I know that the distance from this s, this slow pointer or fast pointer, from this answer, this is my answer, the starting node from this answer is actually m, right? And the distance from head, the head pointer to my answer, that is the first node of cycle, is also m. So why not just update one pointer here? Let's say slow pointing to here now, and slow is not deleted from this thing, and I'll again run a while loop till slow and fast meets, right? And I will move now just one times. Slow will move once here and the fast will move once here. Slow will again move here and the fast will again move here. Since there are equal number of nodes in this traversal, from where to where? From this traversal in this direction, from this traversal to this traversal, since there are equal number of nodes, so eventually they will meet at this point, right? And whenever they meet, I will just say that return this answer dot data. I hope this point is clear to you. I tried to explain you from the very native. Let's code this thing. So I know slow and fast is pointing to one node in the loop where which I was saying that loop exists. What I have to do, I have to update my slow pointer, or let's say fast pointer, to head. So I am, in this case, I am updating my slow pointer to head, and I will say that now while slow is not equals to fast, keep on moving ahead with just one division. So I will say that slow is equals to slow dot next, and fast is equals to fast dot next, right? And as soon as this while loop over, I will say return slow dot data, or you can also say return fast dot data, because both are pointing at the same node. That is the starting point of the loop. So I will, let's say, slow dot data, and I will, in the comment I will say, you can also say return fast dot data, right? And if the loop does not exist, it will not go in this while statement, and after the overall while statement over, that means that the loop doesn't exist, and I will say return -1. I hope this point is clear to all of you. So let's compile and run. And before compiling and running the test cases, it's very crucial to discuss what's the time complexity. So what is the time complexity here? We are just traversing into this list which have the number of nodes as n, right? So we have the total number of nodes as n, but as you can see that there is a finite number of times the slow and fast will traverse in the list, and they will meet at some point. They will meet, right? So the time complexity will be, let's say, k star n. Oh no, not k star n. Let's say the number of finite times is a, because k I have used already. So I will say that a star n, where n is the number of nodes, and space complexity I have not used any data structure to get help to solve this question, so that will be O of 1. And if we just neglect the constant in the time complexity, it will be O of n, right? And since the constraint given is as 10 power 5, which is less than 10 power 8, 10 power 5, and if we solve in O of n, that will be less than 10 power 8, so it will get submitted. If you are not able to understand this 10 power 8 logic, that why it is not giving TLE and it will get submitted, then I made a video on the time complexity analysis, uh, with a question on it. So it must be flashing up here now. You can watch it. So let's just see the compilation results. Okay, so your output and expected output matches, and now let's just hit the submit button. We have taken care of all the cases. There was no such note points here. So okay, so there is something wrong with some of our test cases. So I need to see what I have done wrong here. So I just changed the line that initially I wrote slow is equals to dot next, and then fast equals to fast dot next. Just reversed it, that I am just iterating fast first, and then I am iterating slow first, and it is working fine. So it shouldn't be the case that it should have worked for slow as well as the fast order. But okay, let's see. So I just dry run it again for a particular case, and now I can explain it to you that why it didn't run for that thing. So let me open a page. Okay, so our logic was true, but in the code perspective, there are some more things to handle. So what I saw, that if I write slow first and fast after it, so it didn't work. But if I write fast first and slow next, then it worked. So let's take an example. So let's make a loop first. Let's make a loop of 4 nodes, and I'm saying that the length of these nodes is k, right? So let's make a node again, 2 nodes here, and from our idea, from our intuition, the length of this node was m, right? So that this whole node was n, and k plus m was multiple of n. So if this length is m, then I need, so from here to here it should also be m, right? So there is one node already considered here, so I just have to make one node here, right? And now let's see where start and fast pointer will meet up. So firstly, start will be here, and fast will also be here. So start will, okay, you do that thing, start and fast things, and I will say that after doing those things, you can see that start pointer and fast pointer will meet at this point, right? So suppose if I do what I was doing like I was moving slow first, right? So if I move this slow, okay, slow pointer was then updated to the start, right? So if I move slow here, and then I move the fast to this pointer, then what it will say that the slow and fast does not matches, then the slow moves into the loop and fast now comes into the first node of the loop. You can see the uh, mm, discretion here, like it should not go, the slow pointer should not go into the loop, the fast and slow should must point at this same point, right? That is why that is why now let's make the, so that is why it ran for if I move the fast first and slow first. So let's say if I move the fast first, so fast will point to this pointer, and then slow will move here, right? And still the data is not equal, so fast will move again, and now you can see the data becomes equal, right? Okay, so that was the case. So we saw that thing too here, and okay, so the code is running successfully, and we have seen all the ins and outs of this solution using the Floyd detection problem. Okay, so let's meet in the next video in the tomorrow's GFG POTD of day what? So tomorrow will be the day 90. So stay tuned. And a few last things, that this is my DSA repository. You can start and fork to get help with the source code. And that's my Instagram channel made just for you guys, so that we can connect here 24/7 for any doubts and guidance if you may have. And that's it. Let's meet in the next video. Till then, keep studying, take care, and keep growing. Bye bye.